Hi, so welcome to my first mini lesson. This is on the very first part of dynamics and space, vectors and scalars. So the first thing you need to know is the definition of each. So I would pause the slide right now and write these down if you don't have them in your notes, or say them over a few times and try and get them into your head. Even better still, make a flashcard for each of them. A scalar only has a magnitude. A vector has a magnitude and a direction. So it's quite a common question that comes up in the paper in multiple choice or in the longer paper to ask you what the difference is. And this is the answer. So get it on a flashcard. Now, we've just learned that scalars only have a magnitude, that vectors have a magnitude and a direction. So let's have a look at these examples. We've got forces, we've got a pulling force here, and we've got weight, which is a force due to gravity. Now, does a force have a specific direction? Is he pulling the rope in a specific direction? Is the apple falling in a specific direction? Yes? Okay. So which one of these, scalar or vector, has a magnitude and a direction? Vector, right? So what we can do in here is put force. Now the next one's acceleration. Do you accelerate north to Inverness, south to London? Do you accelerate west when you join the motorway on your way to Glasgow? You do from where I am. It may be different from where you are. But yes, I think if you're accelerating in a vehicle, you definitely accelerate in a certain direction. He accelerated on the M90 north towards Perth. So we're going to put that in the vector section. And what about time? Now, the hands of a clock have a direction. They absolutely do, a clockwise direction. But does that mean that time has a direction? Or is it just the hands on the clock? Does time have a physical direction? No. So time is a scalar. And the last one is energy. You can see where it's going to go. The gap is there, but why? Why? Look at all these direction lines. We pretend rays of light shining out. But that's because energy goes in all directions, not one. Unless you direct it in one direction. But from a light bulb, energy will come out in all directions. You don't say the energy from a light bulb traveled northwest. It doesn't make sense. It's only got a magnitude. You've got 40-watt bulbs, you've got 80-watt bulbs. That's to do with their energy. And they will have a greater or a lesser energy, but not a direction. Right, next slide. Weight and mass. You come across a difference between weight and mass in your National 5 physics course. You may have gone over that already, you may not. So let me explain that weight is that force due to gravity, a force due to gravity, whereas mass is how much matter you are made of, how many kilograms of atoms make you, or how many kilograms of atoms make a bag of sugar, how many kilograms of atoms make a table. Everything's made from atoms, right? Whereas weight is not directly about how much matter a thing is made of. This apple has a mass, but that mass is affected by gravity, and therefore it has a downwards force on this man's hand. Now, I think this man is Mr. Newton, supposed to be, has a force, a downwards force on this man's hand. So which is our vector? Which has a magnitude and a direction? Weight or mass? Hope you got that right. Weight is your vector because it is a force which has a direction, and mass is a measure of how many atoms you are made of. So it doesn't have a direction. It's a scalar. Now, the same kind of problem with speed and velocity. One of them is a scalar and one of them is a vector. And your physics teacher may have used them interchangeably up to this point. But now we have to distinguish between them because one of them is a plain, straightforward scalar with just a magnitude. And one of those words refers to a vector when we give a direction as well. Let's have a look at this first video. Now, did you see the motorbike go past the camera? It wasn't changing direction, it was going in one direction. What was its speed? Was it fast? Was it slow? What would you say? Let's watch the rest of the bikes move off. They're all in a car park, and yes, they have a direction. But is that direction really important? They're not on a long journey. They're just in a car park. Maybe they're going to the exit and then they're starting their journey with a more specific direction. So are we interested in describing their direction? Not really. We're only interested in describing the magnitude of their speed, which seems sensible to me for a car park. So speed is the scalar. It just has a magnitude. He traveled at 14 kilometers per hour. He traveled at 30 kilometers per hour in his car, whatever the speed. That is it. We do not mention a direction, but sometimes a direction is important. Watch this. Sometimes we need to change direction on a journey. We need to turn left, we need to turn right, and our direction is really important. Sometimes we have the same direction. Like I said, we're traveling north on the M90. That would be velocity, if we give it a size as well. What do you think a sensible size for velocity would be on the M90? What's the speed limit? Do you know? 70 miles an hour. That's right. But have I said velocity or have I told you the speed? Did I just say 70 miles an hour? That's the speed. Now, if I say 70 miles an hour north, that's the velocity. Let's try a couple more. 30 miles an hour. You're right, that's a scalar. 30 miles an hour east. That's the vector. Okay. Now, same with distance and displacement. One of them is very familiar to us, the word distance, and that is our scalar. And displacement is our vector. Okay, fine. So which one of those two has a magnitude and a direction? That's right, the vector displacement has a magnitude and a direction. Distance, just a magnitude. So imagine this is a 100-meter circuit, and we start here at the top, and we run 100 meters around it. Our distance traveled is 100 meters. But actually, our displacement is 0 meters. We've gone nowhere. We started here. We finished in the same place. So actually now our displacement is 0 meters. We've traveled nowhere. We've ended up back where we began. So we moved 100 meters distance, but we actually displaced ourselves not at all. We ended up back where we started. So this is where you start to see the difference between a vector and a scalar quantity and why we need those two names. So let's have another go. Imagine that you travel halfway around the track. What's the distance you've traveled? 50 meters. Okay. Now, can you give me an estimate of your displacement? Is it going to be more than 50 meters or less than 50 meters? your displacement across the field? Less than 50 meters. Yeah, I think this is not quite the same length as all of that, is it? So your displacement after you've traveled, after you've run halfway around the track, would be less in magnitude than the distance you've traveled. Now, imagine this is north and this is south. If you've traveled halfway around the track, what is your displacement? Let's say the magnitude is 30 meters. So the displacement is 30 meters south. Now imagine from from there, you run back to the top. This time, what is your direction? North. You've traveled from here to here, north. Yes, you didn't actually run north, but you've gone from here all the way around to here. So as the crow flies in a straight line from start to finish, you have gone north. Okay. Here is an example of lots of different vectors and scalars that we've looked at. I'm going to ask you to pause the video, and then I am going to ask you to write down which one you think goes in which box, and I'm going to do it for you now so you can check your answers. So pause now. Did you get force right? It's a vector. Speed is your scalar. Velocity is your vector. Let's put those two in the same line. Let's put mass with force. It's your scalar. Distance, scalar. Displacement, vector. Time, scalar. Acceleration, vector. And energy, scalar. Did you get them all right? So in my actual tuition groups, we will do past paper questions on vectors and scalars, but there's still much more to learn. So if you're in my Physics Firm Foundation classes, you'll be able to find the next lesson too. If it's not there yet, it will be soon. Thank you for listening. Bye.